Ah, yes, you're growing at that comic, but I bet you in the next 18 hours or so of your life you'll utter that line to someone around you. They'll groan equally, as I'm sure. We're going to continue our work with celestial models, celestial spheres, celestial globes. All of those work to call this. So if you dig out your notes where you have labeled and drawn the celestial sphere, very rough sketch here, we're going to focus our time a little bit more on the North Celestial Pole, NCP for short, North Celestial Pole. We know that objects in our universe can revolve, thus making an orbit. So if this Earth went all the way around, we would have 1 year, and that would be 365 days. Well, 365 and a quarter days, which is why you have a leap year every 4 years to account for those quarter days. 4 quarters adding up to 1 day. The day comes about because of rotation. So spinning about your axis. That is a rotation versus a revolution. This happens pretty quickly, even though we don't feel it. Quickly in the terms of just about 24 hours for 1 day, or quickly at the rate knowing what we're rotating at 1,000 miles per hour. As we have this rotation occur, we can focus above the Earth's North Pole into the celestial sphere and look at the North Celestial Pole. And there happens to be a star nearly directly above geographic North Pole of the Earth to act as the North Celestial Sphere, and that is known as the North Star. This image, it's not a tuma. This is actually a close-up image of the North Star. Its proper name is Polaris. And it is like so many of the stars that you look out into the night sky, it's actually a multiple star system. So you have Polaris A, the biggest and the brightest of the star system. And there's even more close-up that before looked like it was just a connecting piece to the Polaris, or North Star right there. Some of the great things you can do in astronomy related to the world of the North Star is connected with photography. If you were to keep the shutter of your camera open and focused on the North Star, program the digital camera to extend the shutter life, keep it open for say maybe 15 minutes, 30 minutes, however ambitious you plan on doing, you'll see these star trails. And the farther out from the North Star, the longer the star trails are. And that's because they're farther away from this North Star. The North Star doesn't appear to move very much, as that's the center point of which we're rotating underneath. So that's why it doesn't leave too much of a star trail. Here's another image. This one is definitely longer than the previous extended exposure. This one's probably about a 10-12 minute exposure, whereas this one I'd say at least an hour exposure leaving the shutter open. I believe this comes from planetarium or a astrophotography group in Australia. Nope, that's this one I was thinking of. This right here is definitely longer than an hour, probably 2-3 hour exposure, so a good chunk of the evening, and you can see these star trails. And you can even see that the North Star does move ever so slightly across the evening sky. This is a star trail from Capitol Reef at the UVU field station here in Utah. This is a colleague of mine who was formerly a high school student of mine, that she took astronomy, and then she ended up getting a job teaching elementary students in the 6th grade, where there was a lot of astronomy in there. So she called me up and said, I remember in your astronomy class you had mentioned that you taught the adult students in the summer the astronomy course. I said, yep, I still do. She came, and she had a little bit of pressure with her because her father is a professional photographer out at ATK, and so he taught her how to make a night sky image. This was the first one that she did for a test run, and the test run really was not so much to see if the equipment worked, but if she could stand holding the shutter open, because she had arrived, this time we were at Emery County, and she had forgotten the remote to the camera that allowed you to program the shutter to stay open for a longer period of time than just depressing the key halfway down on the camera. And she knew she could not go home after all the great training her father had provided her in creating these night sky images. For example, the key here is to make sure you always have something in the foreground. It really sets off the photo better than if it's just on the night sky. So this was after 5 minutes, and it is the summer, but it is a desert, and it gets very, very cold. And so she decided she was going to go for a full 30 minutes. And I was there to support her. Her husband was also there to support her. And by support her, we were terrible. We would just kind of make fun of her and just say, "You're not going to be able to make it to 30 minutes. That's crazy. You're insane." But she was incredible. She was quite the trooper. About the 15-minute mark, she told us that her finger was about to die. It was so frozen, and she was going to have to switch fingers. After that 15-minute solid investment she did, all of a sudden, her husband and I became actually supportive. We're like, you can't, you've invested 15 minutes, don't switch fingers. And she just had to. And she did switch fingers, didn't lose the image. She stayed on the shutter button, halfway depressed for another 15 minutes, and she came out with this marvelous, it's one of my now favorite star trail photographs here. So you see definitely a longer period of time. What I love about this is you can see that moment where she switches fingers. She doesn't lose the photo, but you can just see that great moment. So I encourage you, if you have access to a digital camera, try out making your own stellar trail photograph for the group. This one right here just shows you how much you have learned already in this course. If we were to ask you at the beginning of the trimester, what star pattern are you seeing here? You'd probably roll your eyes at me. We have ourselves a very bright streak here as a clue. And another clue for you are these 3 stars that form this straight line that our eye tends to go to in the winter sky in the northern hemisphere. So winter, 3 stars, the brightest star trail of them all. So this is Sirius, and those are the king stars, or Orion's belt. So you're looking at the asterism of Orion at night in a star photo. As an astronomy instructor, we have to provide the obligatory star trail pattern image against the backdrop of Stonehenge in the United Kingdom, in England specifically. We'll talk more about Stonehenge a little bit later in this lesson. Another one from the UK. This is a star trail pattern image from a woods in the country of Wales in the United Kingdom. With the North Celestial Pole, we want to recognize this area right here. So you might want to shade this in or just highlight it within your own notes and label that that area is known as the circumpolar region, meaning that no matter the time of year, no matter the season, you will have these stars, as long as it's clear night, always be visible. Now there is a region in the southern hemisphere that's also circumpolar, but we concentrate on the northern hemisphere here with you as the fact that we live in the northern hemisphere, and that's what we're going to focus on. So circumpolar, that's usually about 0 degrees down to about 20 degrees. This is the area where the stars are always visible. For example, the Big Dipper. You probably haven't thought too much about it, but you don't actually go out at night and look up and think, oh, is it the right time of year to see the Big Dipper? And you don't do that because it is a circumpolar asterism. It's always visible in the night sky of the northern region, providing you have clear skies. There's an animation for you, very much sped up. You're not going to see the stars move this quickly around in the evening sky, but we have the North Pole right there, Polaris, the star, and then little blips lighting up of different asterisms that we would call circumpolar, meaning they're up any night of the year. There is the Big Dipper here. This one highlighted is Cassiopeia. We'll look more at some of these star patterns in another lesson. So as the Earth rotates, there is also this longer motion that the Earth is doing. So rotation of this Earth, obviously sped up again, is just under the 24 hours for our 1 day. Then we have the Earth as it travels around our sun, and that is 1 year. There's also another motion that the Earth exhibits, and this one is much, much slower. And this, like all the other animations so far today, is very much sped up for you. If you were to watch the North Pole of the Earth, and you watched it from this overhead view, and you could also do the South Pole as well, we're talking Northern Hemisphere all the time, this circle pattern that it makes, this is if you're looking at the Earth from a bird's eye view or above the Earth, and that is the North Pole, so you're looking straight down or into the screen here, you would find that the Earth makes this motion that's known as precession. And we'll show you how sped up this motion is right here on this animation, because the time that the Earth takes to make one cycle of precession is about 25,000 years. Sometimes you'll see 26,000 years. So 26,000 years. So definitely you can see how quick this animation really is picturing the precession for you. With this precession being focused on the point that is directly above the Earth's North Pole, you have some interesting effects. This is just another image, another look at the precession. So this making out this precession circle against the celestial sphere. So instead of looking down at the top, this is looking out from Earth above into the night sky. And right now, when we use our North Pole of the Earth to match up with the North Pole of the celestial sphere, the norths happen to line up right just there with Polaris. You can kind of think of precession as this motion similar to watching a top slow down. It starts to wobble. Now, of course, in the world of science, we want to sound more smarticle than saying celestial bodies will wobble. So we'll say precession, this circular path that the central point or axis of the Earth makes. And the Earth is currently about 23.5 degrees from that geographic north center. If you were to have the globe standing straight up, we're actually tilted about 23.5 degrees from that central axis. And when you have this circle of precession, and every 25,000 years, you're not always going to have the North Celestial Pole be the North Star of Polaris. We may have in 14,000 years from now, the closest star on this circle of precession might be the star Vega. So we'll have a North Star in 14,000 years, but it just won't be Polaris. It'll be likely the star Vega. This Polaris is a great star for the North Star because it is pretty much right on that circle of precession. Way back in ancient Egyptian times, the North Star was Theban. And Theban wasn't quite as nice on this precession circle, but certainly better than maybe the star Deneb out here, Cygnus the Swan, that may have to act as a North Star for future generations. Here's just another look at this circle of precession and how Polaris is our current North Star. And as time goes by, we may need to rely on Vega, just as the ancient Egyptians once relied on Theban for their North Star. So this is the precession of the Earth. This one circle of precession takes about 25,000 years. And these little dots are just representing some of the stars that are likely candidates to be future North Stars once we've moved our precession past the point of Polaris. And one final look, another image of this circle of precession and how these stars may act as North Stars for future and past generations. The Earth's precession plays an interesting role with the fact that we live in the 21st century with the famous star patterns that make up the Zodiac ring. So with your notes, you can just draw a circle right here. You don't have to necessarily label each and every one of those items that make up the Zodiac ring. We'll walk you through the activity here. You just need to have in your notes what the main idea, take-home message from this is, and I'll highlight that in a moment. In the picture above, so this zodiac ring right here, you are right here, absolutely ginormous on this planet Earth. This is supposed to represent the Sun, Mercury, Venus, Earth, and a ginormous you. In the picture above, which zodiac sign would be behind the Sun? So behind the Sun. All right, you are looking into the Sun, not directly. You would never do that. That's dangerous to your eyes. One of the things we like to do is take you outside with eclipse glasses and show you the Sun. Unfortunately, we can't do that through this medium here today. But just as a point of reference, we're saying the front of you is towards the Sun, recognizing that's day. If you were to rotate 12 hours, then that would be midnight. So daytime, nighttime. Get you a little perspective going on this image. All right, so which zodiac sign would be behind the Sun as seen from the position of Earth in the drawing? So here's the drawing. Here's the Sun. So behind the Sun, behind the Sun. So I'm going to just take and make a straight line between the Earth and the Sun and the zodiac signs. So I'm just putting a straight line there. Try to make it a little thick with all these tiny lines. So in the picture above, which zodiac sign would be behind the Sun as seen from the position of Earth in the drawing? Well, that's going to be Aries right here, Aries. Item 2. Which zodiac sign would be seen overhead at midnight for the position of the Earth in the drawing? As mentioned before, midnight, but here the star pattern is Libra. So let's say that a human life form pops into existence here at this moment in this position of the Sun, the Earth, and the background stars. Do you think someone would label you, if you popped into existence right here, do you think someone would label you an Aries, or would they label you a Libra? You would be labeled an Aries. And this is the frustrating thing when I do star parties when it's someone's birthday. They'll say, oh, I'm an Aries. Show me where the Aries star pattern is. And I have to point to the ground because I'm pointing to 6 months later when the star sign of which you're assigned at your birth is going to be visible in the night sky. Astrologers use what are called the sun signs, so what's behind the Sun at the time of your birth, rather than your moon sign. So this person's moon sign is Libra, and that's what was visible at the time of their birth in the night sky. So what we're going to do on item 3 is for you specifically, you're going to figure out what your moon sign is and what your sun sign is. So let's clear this mess up just a little bit. So with the example of Clark Kent is a Pisces, and so that is the sun sign. Remember, that is behind the Sun at your time of birth. So I'm going to draw a line as best I can from Pisces to the Sun, straight line. So the position of the Earth is being called a Pisces. The Earth is actually over here. Remember, you can't see what your star sign is, Sun star sign is, on your date of birth. What is in the night sky is your moon sign. In this case, it would happen to be Virgo. So if you are a Pisces, the zodiac sign behind the Sun is Pisces. So whatever star sign you happen to be from earlier in the course, you'll write this here, and then just draw a straight line from that star pattern area through the Sun to the opposite side. The zodiac sign overhead at midnight is Virgo. Exit out of that there. And so let's do another example for you. Let's say that you're Gemini. So I'm going to draw a line from Gemini, somewhat straight line. If I'm Gemini, Gemini would go here, and the Earth is here, and my star pattern that's visible at night is not Gemini, even though that's what I'm called. It would be Sagittarius. If I'm Aries, so I draw a line from Aries, the Sun, I'd put Aries up here, Libra here. If I am Leo, draw a line here. If I'm Leo, I'd put Leo up here, and then Aquarius is opposite that. So that's how it works. One more example. If I'm Capricorn, draw the line here. The star pattern I see at night on my birthday is Cancer. 6 months later, on my half birthday that people love to celebrate around here, I found when I moved here, would be able to see my star sign, or the sun sign that astrologers use. Continuing on this page, how many astrological zodiac signs are there? Well, we've been talking all course about 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12. These are the 12. Right here, you've seen those. The next item is going to be answered in going back to your notes about the celestial model. You have this item here, and by the way, the question we're answering is how many astronomical zodiac signs on there. So where you have this celestial sphere, you want to write down what an ecliptic is. The ecliptic is basically the path that our solar system traces out, relative to, say, if you were zooming out and looking down at our solar system instead of just the celestial sphere. The ecliptic is the path of our sun and our planets and our moon relative to us, if we're looking and watching the motion and tracking the motion of the sun. The ecliptic, essentially path of the sun, is what I'm going to be saying quite frequently, even though it includes all our planets. In this area right here, you're going to draw an image, or in your notes, near your celestial model. You draw a circle representing the celestial sphere. You just draw a circle for the Earth in the center. This line is your equator of the Earth, and it's also the celestial equator because we extend the Earth's equator out. And then at an angle, you're going to draw the ecliptic. NCP is short for North Celestial Poles, directly above the Earth's North Pole and Southern or South Celestial Pole. This ecliptic may not surprise many of you. This ecliptic is about 23.5 degrees from the celestial equator. So what you want to have somewhere in your notes, you got a circle for the celestial sphere. Here's the Earth. You've drawn an oval, hopefully better than that. That is your celestial equator. And then tipped over to the side is another oval, and that's your ecliptic. A sketch like this will do you. Ecliptic, path of the solar system, path of the sun, planets, including our moon in the path. There's another visual to try and represent. Again, you're ginormous. Looks like you're bigger than the sun or the moon here. So sun peeking there. We have the moon. And the ecliptic is this path. Now, of course, just as there's not a line saying this is the equator, there's not a line in the night sky that says, you know, this is the track that the planets will slide along. But it makes it handy when you're out there observing at night and you want to find Mars, and maybe Saturn is up as well. You don't have to look and go, oh, there's Mars, and turn your head 100 degrees and try and find Saturn. Once you find one of the planets, it's pretty simple to find others if they're going to be visible that evening. They'll follow this ecliptic. There's a photograph of this. It's a mega shot where you have our moon, Venus, Mercury, Mars, and Jupiter all in this sky shot. And so this is the ecliptic that we're talking about here. This path right there that our sun, our planets, and the moon follow. All right, so beginning of the course, we told you zodiac loosely meant circle of animals. In the world of astronomy, we have a much more specific definition for what the zodiac is. We're going to go back to this smashed out image of our celestial sphere, where there are 88 constellations, and there are all kinds of wild and crazy shapes. Reminder, that they were trying to get those famous star patterns. There's the Big Dipper asterism. They were trying to get those, and that's why they're this strange shape. Plus the fact when you flatten out something spherical to a flat shape. But the ecliptic is defined in astronomy. Follow the cursor rather than try and see the red line. The ecliptic the zodiac is defined as what the ecliptic will pass through, what the ecliptic passes through. So if let's get that out of the way for you. If we look to see the zodiac as to what the star patterns pass through the ecliptic to make it the zodiac, of course we have Pisces, Aries, Taurus, Gemini, Cancer, Leo, Virgo, Libra, Scorpio, Sagittarius, Capricorn, and Aquarius. We also have this region right here. Let's see if I can highlight it. We have that region that the ecliptic most certainly passes through. So to an astronomer, there are 13 stars, patterns, or constellations in this case, as they are regions of the night sky, that make up the zodiac. So this is a better image of the zodiac in that it includes this constellation that the zodiac consists of. And this is Ophiuchus. There's a lot of different ways to pronounce it. That's probably like the second preferred option. But I'm always stumbling over my words, so I like to be extra cautious and just go with Ophiuchus and not embarrass myself further. And Ophiuchus is the sea serpent, or the serpent bearer. Sorry, not the sea serpent, the serpent bearer. You can see clearly there's a person holding snakes, right? Here's a Renaissance rendering of Ophiuchus next to Scorpio. So how many astronomical zodiac signs are there? There are 13. So an astrologer would say 12. Now your astronomer is probably going to say 12 as well, because they don't want to have to sit there and say, well, there's 13 because the zodiac is really defined as what the ecliptic passes through, and the ecliptic is the path that our sun and solar system makes 23.5 degrees from the celestial equator. They're probably not going to go into that, so they'll probably just answer 12. But since you are in astronomy class, just like we wanted to make you aware that a constellation has a set meaning, it's one of the 88 regions of the night sky, kind of wanted to make you aware also that the zodiac is very specific in terms of astronomy. Now, number 6, why don't astrologers include Ophiuchus? I want to take a moment and want to have you pause so that you'll take some time and think about that and jot down an answer and unpause, and we'll go over that. I'm sure you recognize the 12 is easy on the astrologer to match up with the 12 months of the year. So astrologers don't include Ophiuchus, as when the zodiac star patterns are established for the means of astrology, for the purposes of how your time of birth under various celestial patterns might affect your personality or characteristics. Ophiuchus wasn't included. This isn't to say astronomers all of a sudden saw Ophiuchus was there. It's just one of those things that Ophiuchus hasn't been included in astrology, kind of the 12-month, 12-star pattern thing. Now, there are some philosophies of astrology that will consider the 13th zodiac sign, Ophiuchus, as part of their horoscopes or life scopes. Before we wrap up looking at the celestial sphere, we want to give you an insight into the item I mentioned at the top of this, is where the zodiac ring and the Earth precession have a little bit of a connection that most people don't recognize in the context of astrology. So I'm going to resort to probably one of your favorites. This is way back from the 90s. You might think, how is something from the 90s my favorite? But I'm sure you all have heard of Bill Nye. And he's going to set up for you what I'm going to wrap up page 9 with.
You believe in astrology?
A little bit.
What makes you say that?
Because I can see the stars.
Whoa. She thinks astrology is a thing because she can see the stars. Let's just do that one more time, my friends.
You believe in astrology?
A little bit.
What makes you say that?
Because I can see the stars.
third time's a charm. Every time.
You believe in astrology?
A little bit.
What makes you say that?
Because I can see the stars.
All right, I'll let it play.
You probably know your sign. Or do you? Try this. Wait for your birthday, then stay up all night and watch where the sun rises. It will pass in front of one of the 12 constellations of the Zodiac. They say I'm a Sagittarius. So on my birthday, you might expect the sun to rise in the constellation Sagittarius. And it did, 2,000 years ago, when the Babylonians made all this up. But it doesn't now. In the last 2,000 years, the Earth has wobbled like a top. So now on my birthday, the sun rises in Scorpio, not Sagittarius. So maybe you'd have to be a Capricorn to be a Sagittarius, and Scorpios would have to be Libras. See, astrologers are off one full sign. In 2,000 more years, they'll be off 2 signs. But they don't seem to care. So, in these reflective moments, I ask myself, am I a fun-loving Sagittarius or a sexy Scorpio?
Before we do one last thing related to the celestial sphere with you, let's just pause for a moment and look what you might have in your notes thus far. We want to have the concept of the ecliptic. The ecliptic, if I have a celestial sphere, the Earth in the center there, and I extend the Earth's equator out, that becomes a celestial equator. Tilted to that is the ecliptic. And the ecliptic is the path that the sun, planets in our solar system, and our moon trace out. So when we were to watch and trace out the path of the sun over the course of a year, we would see the ecliptic that would be mapped out relative to us. With the celestial sphere, we looked at the north celestial pole, Polaris, and how in our time frame of being on planet Earth, we have Polaris as our north star. Because the Earth has this motion of precession, that if you were to watch it overhead, every 25,000 years it completes a full cycle or circle of precession. And because of this precession, it causes about every 2,000 years, because if we call it 25,000 years for one precession, divide by the 12 zodiac signs that the astrologers use. 12 goes into there twice, 24, 1 and 0, so 0, 100. So up here, that's why I'm going to say 2,000, just as Bill Nye said. Every 2,000 years, the sun is tipped over by one constellation. Now, I don't mean the sun itself is tipped over. I just mean that this zodiac ring is moved over or shifted by one constellation every 2,000 years, as the Earth has that circle of precession, with the Earth being there and the axis completing a full circle. This right here was just to point out to you that the astrologer sign that you're given is your sun sign rather than your moon signs. When you go out at night on your birthday, you won't be able to see your astrological sun sign in the night sky. You have to wait 6 months. The Ophiuchus star pattern here was just to connect back to the beginning of this lesson with the ecliptic. The official definition in astronomy of the zodiac are any of the star patterns that the ecliptic passes through, or any of the constellations. So that's why astronomers view 13, whereas astrologers view the 12. So a little summation there of what would be beneficial to have in your notes. Those of you wondering, okay, so if I've been reading the wrong horoscope my whole life, what is my star sign actually? These dates that are in the bolder font for you, those are the ones previously in the notebooks that were given to you, so you could pick out what your star sign was to do the horoscope activity. These that are in the lighter, so I'll put little stars, that's a star apparently. These little star ones, those are updated. Updated meaning we're in the 21st century. It's 2020, so about 20 years past the time the Babylonians established the 12 zodiac star patterns. And so the sun has tipped over. Or the cycle of precession has caused the sun to now have a different star in the background. We've been using Clark Kent as our go-to example. He's a 28th of February Pisces. So Pisces here, 28th of February, he would actually now be in Aquarius. And I imagine many of you, if not all of you, have shifted over by one zodiac star sign. Then there's this group right here. It's our friends who have never read a horoscope in their life that was written and directed to them. So if your birthday falls between 30th of November and 17th December, you're an Ophiuchus. And the horoscopes aren't texted or emailed to you. Wait. So you're telling me I'm an Aries now? Let me see that thing. Think about it. Taurus, the bull. I'm an Aries now.